Oh, hello. About 80,000 years ago, a meteorite fell to Earth and landed in what is now modern-day Namibia. This was called the Hoba Meteorite. And as it fell to Earth, it slowed down because of the Earth's atmosphere to terminal velocity. It hit the ground at about 720 miles per hour, but it didn't make very much of an impact. Once it fell, because it wasn't going so fast, it became the largest intact meteorite that we know of. On the ground, the Hoba Meteorite, the chunk of it that is left, is 60 million kilograms. That's a lot of kilograms. It is the single largest meteorite that's intact on Earth and the single largest natural source of iron in one chunk on the planet. It fell to Earth thousands of years ago. It's a giant source of metal, and it landed in Africa. Kind of sounds like a real-life Wakandan vibranium meteorite, doesn't it? Sometimes the truth is just as cool as fiction. Hello, and welcome to another edition of Because Science Live, where everything is live, including us, because we're alive and we're watching it, but everything is coming up off the top of my head. I'm taking your questions and comments and reactions and trying to do a little bit of something special for you in real time. So, Lee, what do we got going on across the YouTubes and the Twitches and the et ceteras?
Hey Kyle, are jellyfish even fish?
You know they're not though, right? Fish, bony fish, like vertebrate, it's right in the name. They have bones. So jellyfish evolved well before bony fishes. So some scientists like to call them, instead of jellyfish, like to call them jellies. It's just easier and it gets around any kind of confusion. For the same reason, many scientists now call starfish sea stars. And if you want to be fancy about it, you can call octopi, which is technically wrong, octopuses. But it has a bad mouthfeel when you say it. You could call them octopodes if you want to sound like a real jerk, though. So try that out. What else we got?
How does the Wakandan cloaking work? Is it light bending?
I think we did this question 2 weeks ago on an edition of this live, but it's worth restating. So Wakanda, at least in the new film, is protected from the outside world by a kind of light shield that redirects light so you can't see that Wakanda, the city, is there. Not just the nation. So how would that be possible? Well, you'd have to have a city with some kind of metamaterial or field, some kind of force that is interacting with incoming photons of light such that those photons, their paths are redirected so that they will not go towards jellyfish. They will not go back towards your eye, so you will not see anything that is inside of this bubble. Or, like some metamaterials do, materials that we have made in the lab, it could bend simply around this object that it's cloaking and never come back to your eye through reflected light. If that happened, then you would never see Wakanda. How do they generate it? I do not know, because it's completely permeable and ships can fly through it. So, I don't know. Good question, though. What's next?
Can black lightning stop bullets with lightning?
Ooh, can black lightning stop bullets with lightning? So, it depends. Lightning is a electrical discharge. So when you have a large buildup, let's do this. When you have a large buildup of charge in a cloud, charges build up because the air is circulating and it gets little particles in the air, charges. Let's say it's building up negative charges at the bottom of the cloud. At the ground, it is inducing then, creating because of itself, a large positive charge. Now when this difference gets large enough, it needs to rectify itself and become neutral again, and what that looks like we call lightning. And there can be a billion joules of energy in a lightning strike. It's a lot, but lightning also happens very, very quickly, and bullets are very, very fast. So what if a bullet, I'm going to exaggerate the size, not to scale here, what if a bullet passed through a lightning bolt, like black lightning could put out? Well, XKCD, Randall Monroe, he did a little blog post on his What If website of XKCD, and he calculated, and I also did this for lightsaber bullets, that episode, that the bullet is traveling fast enough that it doesn't have enough time to be heated by the lightning bolt itself. Lightning bolts aren't very thick. They're about this thick, like literally this thick. So a bullet will cross this amount of distance in a very short amount of time. That's actually not enough time for, even though this has a lot of heat energy, it's not enough time for that heat energy to get into the bullet and fully vaporize it or melt it. So if black lightning was shooting a lightning bolt at a bullet in this direction, such that it would pass through horizontally, then it wouldn't be able to stop the bullet. If he were to direct a lightning bolt directly at a bullet, so the bullet was going down the channel, it would have enough time to get heated up because it is traveling and being heated up the entire time. So black lightning could stop bullets with lightning if it was in the right spatial orientation. He's a smart character, he would know that. What's next?
What's the second largest intact meteorite found on Earth?
I don't know. I have no idea. This is a lot, though. The Hoba Meteorite is actually, politicians do this. They just redirect if they don't know the answer to something. Hey, beautiful question from a very good-looking person. You know what else is interesting? The Hoba Meteorite, this 60 million kilograms, 60,000 tons, was actually 66 million kilograms when it fell to Earth, but because of erosion and because of dang vandals and people chipping off pieces of it, it's lost 6 million kilograms since it's fallen to Earth. So the second largest meteorite on Earth is smaller than this. I think it's like 32 million kilograms now that I think about it. But there you go. What's next?
Would the Hoba Meteorite have any exotic metals in it?
Meteorites have to be pretty big to get to the ground. They have to be larger than 25 meters across, as NASA estimates, and they have interesting chemical compositions. This one, the Hoba Meteorite, was mostly iron, and when it hit the ground, it's mostly iron, but they contain a lot of exotic materials in them, just like your question. For example, one of the ways we have found diamonds on Earth is not just through their common formations, which is something we'll get into in a future episode, wink, but also we found them inside of meteorites. We found micro nano diamonds, tiny bling, TM. We found that inside of meteorites, so we know that diamonds form in space somehow. So yes, you can find very exotic things that don't usually form very easily inside of meteorites. So, could it be vibranium? In real life? No. In fake life? Yes. What's next?
Would Wolverine have a belly button?
Oh no. This is along the lines of another question I've never wanted to do, having to do with another kind of thing that's removed from you sometimes when you're a male child. If you're a Wolverine, and I said it, now it's out there. Don't ask me. But would Wolverine have a belly button? Are you saying would his umbilical cord grow back every time? Oh, I don't know. But from X-Men canon, it seems that a lot of mutations are activated during times of stress, and in the comic books and the TV shows and the movies, it seems like that happens a lot when the X-Men or to-be X-Men or mutants are children or teenagers. So I don't think Wolverine's umbilical cord would grow back if his mutation is activated later on in life. But if he had it since he was a baby, I don't know. And I don't want to know. But I bet you do. I'll put it on the list. What's next?
How would you cut vibranium?
I've been asked a lot about how do you mine vibranium if it absorbs kinetic energy. Let me put it this way. So, vibranium is so confusing because it takes a property that is intrinsic to motion, kinetic energy, and it separates it from something else that is intrinsic, a property that something naturally has, always. And it separates that property from momentum. Kinetic energy and momentum, relativistically speaking, are more or less the same exact thing. So it is very hard to just take out kinetic energy and say, oh, what happens? Yeah, okay. But here's one way to think about it, or one way that I have thought about it as I have racked my brain trying to think about vibranium all day. So here is a wall. If I fire again, not to scale, if I fire a bullet at that wall, like this, and it impacts the wall and embeds itself in the wall, where has the kinetic energy of the bullet gone? The kinetic energy of the bullet, if it smashes into the wall and stays there, has completely dispersed itself in deforming the material of the wall and heat and sound and maybe light. All of the kinetic energy is gone. The momentum, though, didn't go nowhere. It's proper grammar. If the wall is attached to the earth, and the earth, again, not to scale, the earth is not curved that much, but it isn't flat, that's for sure. If the wall is attached to the earth, and you fire a bullet at the wall, all the kinetic energy goes into the wall and is dissipated. The momentum, technically speaking, which is the best kind of speaking, does turn the world a little bit. So how can you mine vibranium? Well, what I'm getting at is that you can still damage something that absorbs kinetic energy. You can still deform it, even if it absorbs kinetic energy. So you could still, in theory, deform vibranium. It would just, the energy that you're putting into it, a lot of it would go away. But the momentum wouldn't. Honestly, it's really confusing. I don't know. Ask Marvel, and then ask them to ask me, and then we can make it canon. What else we got?
Do meteors simply burn off the parts they heat up, or do they condense, or a bit of both?
Okay, so, consistency. When a meteorite falls to Earth, it looks like a blue marshmallow. That's not true. It looks like this. Also not true. But it's like this. A lot of people think that a meteorite heats up in the air because of friction. That's not true. What happens is the meteorite is going so quickly through the air that let's be very basic here, that a plug of air directly in front of the meteorite's path of travel is being compressed. And in basic chemistry and physics, you learn that if you compress a gas, it heats up. And you can test this for yourself. Try to pump air into a bike tire with a bike pump really, really fast or really, really hard, and you can touch the pump and the pump will actually feel a little bit hotter. So you can prove this to yourself. Anyway, as a meteor travels, it compresses the air in front of it so hard and so fast, the thing is traveling kilometers per second, that this air heats up enough to start melting away the layers on the outside of the meteorite. And as that happens, layers fall away, and then the next layer starts to melt. If this gets hot enough and it breaks apart, it can blow up, like the Chelyabinsk meteorite did over Russia in 2014. And when that exploded, you have to double check me on that. When that exploded, it created an airburst that shattered windows for miles and hurt over 1,000 people. Pretty serious. But if it doesn't have an airburst like that, well, it still can. But if it's not as catastrophic as that, the layers slough off and the air is compressing, but that action is slowing down the meteorite. So at some speed, the meteorite will slow down enough that it is not being heated anymore. And at that point, a glassy, almost crystalline layer will form on the outside of the meteorite, and this is called the fusion crust. And it falls to the Earth with a fusion crust on it. And not only can that change how the meteorite looks, it can look really weird, this compression heating can change how the meteorite is shaped as it actually melts as it's going through the air, like the Hoba Meteorite did. What was the question?
I don't know anymore.
I don't know either, but I'm sure this answered it.
Cool. Next question. Could the Hulk jump into orbit?
A lot of good questions today. Could the Hulk? I hate scale. Could the Hulk? Oh, yeah, come on, big muscles. Could the Hulk jump from the Earth into orbit? Well, I'm actually going to be getting into something kind of along these lines in a future episode, which I won't tell you what it is. You'll have to watch the next vlog. But even if the Hulk could produce the amount of force it would take to fling him into space, that force would press on the ground beneath him so hard that he wouldn't get a whole lot of upwards motion. His legs would just go into the ground. Just toosh, straight in. Can't say more. There's a future episode on something like this, so stay tuned. But no? What's next?
How much does the sun weigh?
Dang. It's a basic question that has a very real answer. I don't know what the mass of the sun is off the top of my head. But it has you know what the mass of the sun is? 1 solar mass. Oh. They're asking what the weight of the sun is?
Yes.
Because that's such a weird question. The sun only would weigh something under the gravitational influence of something else. So if the sun came to Earth, it would be 1 solar mass times 9.81, let's be technical, times 9.81 meters per second squared. And that would give you a value of newtons if you multiply it by kilograms. And that would be the weight of the sun. I know the weight of the Earth. Does that count? Man, so many comes into my brain, then straight out. 6.06 times 10 to the 24th kilograms is the weight of the Earth. That, and it takes 4.81 kilojoules per kilogram to heat up water. 1 degree. Engineering school's paying off. What do we got next?
Do you know where the flattest place on Earth is?
Oh, where the flattest place on Earth. No, I do not know offhand. I would know though. It depends on your scale. Not like this. Not like the weight of the sun scale. It depends on what you are measuring. So across what distance? There could be the flattest state in the United States, for example, but that's because you'd have to measure it over miles. Then you could say that Iowa per mile is the flattest or something. But the flattest place on Earth, if you're measuring down to a foot, would be very different. So I do not know what the flattest place on the planet is. I just know that the Earth is not flat, and it depends on your measurements. A lot of people ask me to prove that the Earth isn't flat, that I don't have to do that. The burden of proof is on people who have seen photos of space, and you know what, let's move on.
What would be left of the Tesla Roadster if it came back to Earth?
Ooh, another question that we covered on a previous Because Science Live, so I will ask you to go and watch that one. Let me just say that some considerations would have to be made because stuff might blow up. What else we got?
What happens when a lightsaber hits vibranium?
Just can't get enough lightsabers, can you? Lightsaber, vibranium. I can tell you this. A lot of the energy, a lot of what makes a lightsaber dangerous, most of it, all of it, is the heat that it is able to transfer to something. So if a lightsaber is a hot coil of plasma. It has heat energy that it transfers to objects over certain time periods and melts or vaporizes those objects very quickly. Temperature is also a way of measuring the kinetic energy of particles. And what absorbs kinetic energy? So, if a lightsaber with a lot of kinetic energy, a lot of temperature inside the plasma mass, hit vibranium, a lot of that kinetic energy of temperature would be going into the vibranium stored some way and not into destroying the material itself. So, I think I said this in the Captain America's Shield versus a lightsaber episode of Because Science. Because there's not enough data, there's not enough canon either way to say what exactly the temperature is of something or how exactly vibranium works, you could say that it would temper the temperature damage of a lightsaber at least somewhat. So, bring a Black Panther suit to a lightsaber fight. Oh, that sounds awesome. What else we got?
Does lightning strike in the Arctic?
Man, good questions today. I have no idea. Does lightning strike in the Arctic? I mean, it still has weather there. Yeah. I don't know. Look it up and tell me in the comments. I mean, why wouldn't it? Right? You can do a quick calculation. The average number of lightning strikes per year on the face of the Earth, the average width, hey, we already went through this, the average width of a lightning bolt, and then you take the surface area of Earth, and if you do the math correctly, you can show that lightning will have struck almost every bit of surface area on Earth on average. So it has to strike in the same place more than once. Now. But it does that anyway. That's what lightning rods are. What's next?
How big do wings have to be to lift a normal person?
Well, that's a hard question because you can do the physics of it, but then there's also biological limitations to those physics, right? So, the largest birds are condors and these grand soaring animals aren't that heavy. They can't be heavy. 10 to 20 pounds. Or, a few, the equivalent of kilograms. That's still pretty big, but their wings have to be like 6 or 7, no, that's too far. Like 5 meters across. So these birds are a few kilograms, but their wings are absolutely ginormous in wingspan. All of these numbers can be off. But the gist of what I'm saying is that the wingspan gets much, much bigger than you think it should get as the weight goes up and up. So the biological restriction is that why aren't there birds that are people-sized? Well, to evolve that way, you need different musculature, different bones. Pterosaurs were human-sized things, but their wingspans, one of the first flying things aside from insects, their wingspans are absolutely enormous. Go to your local museum and check out their dinosaur exhibit. They're technically not dinosaurs, but they may be included in that section. We're talking about wingspans in the 5 to 8 meters. It's a lot. So, in theory, you could have, like, you see those I'm rambling. You see those old-timey videos of people trying to flap off of their roofs or off a high thing with giant old-timey wings, and there's also like a weird airplane with like 16 wings on top of it, and they think that's gonna fly. The reason physically that those people aren't flying isn't necessarily because the wings aren't big enough. It's that you don't have the musculature to flap those wings. So you'd have absolutely enormous muscles to go along with the size of the wings, which increases the amount of muscle you need, which increases the wing size you need. So there's some biological limit. I said a lot of stuff there. What's next?
Is a high-frequency blade like in Metal Gear possible?
High-frequency blade from Metal Gear Revengeance? I don't know. Raiden has it. high-frequency blades I've never looked into. The idea is that if something is vibrating very, very fast, would it be able to cut through something better? And I think this is close to something that I have always heard as a kid, as like one of those science truisms, is that if you, and this is in the new Flash show on the CW as well, if you vibrated your hand fast enough, you could put it through things. Why? Same with the vibrating sword. Why would that help? In the canon of the sword, I imagine that it might be some kind of friction, and there are things that are friction heated. Look up friction welding on YouTube. You can just move things so hard and fast against each other that it just melts. And it's very, very cool. I don't know if that applies to high-frequency swords, but that might be a line of reasoning. But you cannot, just vibrating something, not talking about friction or heat or anything, doesn't necessarily make it go through something better. The Flash isn't phasing through walls because he is vibrating, even though the show says that. There is still repulsion between electrons. That's why you've never really touched anything. Not even the ones you... Hey, what's next?
When feeding a mogwai after midnight, are time zones taken into account?
Don't feed a mogwai after midnight, and don't get it wet. I imagine that time zones have no difference, no effect on a mogwai. Oh, this would make a fun episode, actually. I don't know how much I'm going to say about it because it sounds fun. Anyway, I don't think time zones have any effect on mogwai because many animals have biorhythm. Not to sound too hippie-ish, but there are processes in our bodies and in other animals' bodies and organisms' bodies that are regulated by the time of day that it is, based on cues like light and other things moving around. So, for example, I have a flask of dino flagellates in my house that they will only produce bioluminescence if you like poke them a little bit. They're like tiny little floaty guys. Only if it's been dark where they are for at least 30 minutes. So they have some sense of what the day-night cycle is. Now, humans get around that day-night cycle with artificial lighting, but to these single-celled organisms, the only lighting change could be the sun, so they think it's a day-night change. All that being said, mogwais, being animals and not people, probably respond based on the same kind of rhythm cues to the day and night cycle. So, after midnight is probably just an indication of how dark it has been for how long. So let's say 6 hours after it got dark outside, don't feed them. And then they will turn. Otherwise, you could just go to Australia when it's midnight and just feed them and they would turn, but that wouldn't make a whole lot of sense. What's the trigger? The trigger can't be an artificial imposition of human time zones for economic benefit. It has to be something biological, and I would imagine it is a rhythm based on the natural day-night cycle that humans are messing with. I should make that Do you want me to make this a full episode? Let me know in the comments. Wrapping it up. There's a short question, tiny question.
What do you think about Deja Vu?
We still don't understand Deja Vu or why it happens. It's very weird. A lot of scientists have a lot of theories, but one possible one is that your brain is mistaking short-term for long-term memory. So when you see something, it is being cataloged into long-term memory, and then you're looking at it as though you've seen it before or saw it years ago. But it's actually short-term. It's kind of like a little glitch in the Matrix, which is what the Matrix says it is. Whew, I nailed that. And with that, that is all the time we have for this episode of Because Science Live. I rambled a bit, but that's because it is live, and I want to talk to you directly and extend the nerdy conversations around all of the Because Science topics that we have. It's been another great week. The channels are going along strong, and I love interacting with you more than we have. So let me know if you like the new formats. Let me know what you're doing this weekend. I might not read it, but other people will. Leave comments, questions, and corrections on the Because Science channels, youtube.com/BecauseScience, facebook.com/BecauseScience, and @BecauseScience on Instagram and Twitter. And hey, have a great weekend and be nice to each other, because this is all we got.